So solving functions, we need to just basically undo operations as we encounter them. So we're going to work from outside in. Here I'm going to get rid of the +2 with a -2. Okay, I'm going to get rid of minus with a divide by negative. So I get -3. Okay, get rid of the long. We undo ln with an exponent. So we end up with e to the -3 is equal to the cube root of tan x. Okay, we're going to undo the cube root with a cube, so we're going to cube both sides. So I end up with e to the power -9 is my tan x value. And then the final step, solve for x. We get x is equal to the arctan of e to the -9. Okay, so basically, no matter how complicated the equation looks like, as long as we can undo functions to get to the x, you know, we can. That's all we need to be able to do. And every function has an inverse. Okay, so here I'm going to start with getting rid of minus with a plus. So I end up with square root 5 e to the cos x plus 11 equals 4. I'm going to square both sides to get rid of the square root. Okay, we're going to get rid of the plus 11 with the minus 11. Okay, so I'm going to do minus 11 and divide in the same step here. So I'm going to do 2 steps at once. At some point, we do need to start compressing steps. Okay, so I get 16 minus 11 is 5. 5 divided by 5 gives us a 1. Okay, to solve this, we need to go log 1 equals cos x exponent. So the exponent is equal to 0. And then to solve for x, we just arc cos the 0. And since we know what the inverse cos of 0 is, okay, the cosine, the x value is 0, the angle is going to be 90 degrees, or it's just going to be 90 degrees because the domain of cos, the arc cos function. Okay, so the domain of the arc cos function is not exactly the same as the domain of the cos, so we really should be careful here. So we get x is equal to pi over 2, but although that's the only function, the value that the arc cos is defined for, we have to remember that we're actually solving for cos x. So it's pi over 2, it's going to happen at 3 pi over 2, dot, 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 or we could write it as pi over 2 plus n pi. Okay, that would be a more generalized solution for that. Okay, so for here, we have to be careful because there are some domain restrictions here. Okay, so x must be greater than or equal to 3. Okay, but it actually can't be equal to 3 because I'm dividing by 0 if I let it be equal to 3. So I'm just going to state my domain restriction here. Okay, and then I'm going to go ahead and solve it. And I have to be really careful here because when I solve this, I want to get rid of the denominator. And when I multiply through by the denominator, it is possible to lose one of the solutions. Okay, so I'm going to multiply through by the denominator. So I get x minus 3 is equal to x minus 3. Oh, okay, well, that's great. I'm going to cancel out the 3's, cancel out the x's, and I get x equals x or 0 equals 0. So what does 0 equals 0 actually mean? 0 equals 0 means that the solution is going to be all real numbers. Okay, so x is all real numbers. Okay, so any x will satisfy this equality. However, we have to remember that there was actually an initial domain restriction here. So although everything will solve this, not everything solves this because of that domain restriction. So when we graph this, and I want you to really think about what this graph should look like, but the solution is going to end up being x is greater than 3. That's my solution. So any x greater than 3 will solve this problem. So this was my domain restriction, but that ended up being my solution. Okay, otherwise, without that, my solution would have been x is all real numbers. So what would this then look like? Well, what ends up happening is this graph, if I graph this function, y equals x minus 3 over square root x minus 3 minus square root x minus 3, we're going to get this graph that looks like this. It's going to be a graph that starts at 3, okay, at x equals 3. Actually, I'm going to do this in different colors so it's a little bit easier to see. So x equals 3 is my first, is not quite the solution. That's where my solution starts. And it's going to be all these numbers, okay, along the x-axis. And there's going to be nothing on this side. Okay, so this is what my graph actually looks like. So this is not defined for any x's that are on this side. But for all x's on this side, they are all actually part of the solution. So graph is going to look like that.